So hi everyone, we're the ECE banner display. I'm Nicolette, and we have one more member, but Gianna, but she's not here today. So we're just going to go over what our project is, its features, our roles in it, some specifications and diagrams, our budget, and the summary at the end. So our goals was to create an LED RGB banner display with what's it? Oh, move here. So with text and graphics for the ECE Center for Intelligent Systems. So this way, professors can give the important information what their research students are doing as a display inside the building to show off their achievements. For this display, we're going to have like different colors and text crawls and animations, and that will be done using a camera interface. And then we're also going to have it be able to expand from a single display to multiple. So we have 3 chain displays right now for our budget. All right, and so our features. So we have a custom font we've made ourselves that we displayed on the panel, and it'll also be able to scroll by so we can fit longer messages with it, and also be able to display 8 different colors since we have red, green, and blue, so to make up 8 different colors. And we'll have the memory, a text stored in the memory, so you don't have to have a constant connection to a computer or anything. And we'll also have the power be supplied through an outlet, so we'll have to have some sort of connection there.
Okay, so before we started project, we assigned roles to ourselves. So Gianna is going to be like working on our PSoC program and the code and like integrating the display, like all the hardware with the PSoC microcontroller. Nicola is going to work on making sure that the hardware connects with the PSoC and everything else. And I worked on the command line interface and making sure that the command line interface on the PC can communicate with the PSoC. So after we did that, the first step in our process was choosing the displays. So ideally, we wanted our displays to be 5 by 10, and our letters were planned to be 4 by 2. And the display we decided to choose had 4mm pitch. It was around $40, and we're planning to get 3. And the displays support chain, and they had 12 pins each. So these were our display options. We had 3 and a couple more, but these were like the top 3. We decided to go with the one all the way.
So for our power supply, we went with the LCS. So this one would be enough to power 3 different displays. That's why we chose it. Since each board requires 4 amps of current, this one has 14 amplitude, so we can have so it would support all 12. And just for comparison, these are the other ones we're looking at, but they had too much voltage and we only need to keep it down to 5 volts. And then just like different hardware we just got some wiring and some spade connectors just so we can, power, have a cord for the power supply and have it, a safe connection between us, like nice and secure. So we actually have 4 different wires like connected to the power supply itself. So it would power the 3 displays and also the microcontroller board. Which for the microcontroller board, we went with the PSoC 5LP. We went with this one because we were mostly familiar with it, and the price range was pretty high, but also it was something we already had in our hands, so we didn't actually have to spend that towards our budget. And so overall, we were really familiar with its software side too, as well as the hardware side, and also it had enough RAM because we needed a lot to store the text memory. And other microcontroller boards were not as familiar with it, and also they were pretty hard to get because there's like sold out everywhere online.
So for our software, decided to create a parallel interface so that could very easily customize the displays and change what's going to be on them. So we wanted the options to enter text phrase, like any text, any character, any like punctuation or like special characters also. We wanted an option for the text to scroll across the screen, and we wanted different colors and animations as well. So this is what our current command line interface looks like. So you can just pull it up on any Windows PC after the pilot in C++. So that's the top left main menu. So those are all the options. You can change the text, color, scroll, and animation. You could also do a screen. And so for the text options, we wanted to be able to have two text lines. So like one on top and one on bottom. So those are the two options that you can change. And you can also just go back to the main menu. And the color options, those are the 7 color options that we have. Then the scroll options and animation options, we don't have options yet, but we haven't decided what they're going to be. Yes. So this is a block diagram of our software. So on the computer, you enter the command line interface. You can enter any of those options, including the animation options, which are not shown there, but you can just decide to change one option if you want, or change all of them, and that will be sent to the microcontroller and change those.
So here's our hardware. So obviously this is not just to scale, as our power system is not that much bigger than our display banners. But so these 3 long rectangles here are our displays, and they all have 16 bits of input and outputs on each panel. So that allows us to connect each of them together so they can change the I2C cable. And they also have 4 pins on it, so we can, for like VCC and ground, to connect it to the power supply. So it's all good there. And then there's also a connection between the power supply and the microcontroller board or PSoC too. So there's that has power as well. And there are also all that goes to an outlet cord as well. And they will have a USB cable from the PSoC microcontroller board to the computer or laptop. So that's the only time you can plug it in, and then to update and run the command line terminal, update the board's information, you can unplug it. So that's not there as like, it's only there for a temporary thing.
So in the PSoC program, you can add components. This will assign the pins to different wires, which allows us to connect all the displays together. So on the left are all the pins that we need to power the displays, like all the colors, and the brightness as well. And then on the right is the UR component, which allows the command line interface to communicate with the PSoC board. So the RX is basically the receiver. So that is the component on the PSoC board where that's where we send the bytes into the PSoC board from the command line interface. Then the TX is just transfers. So this is just like a simple like demo. So on the left is just a picture of how all the hardware is connected. So that's only for one display right now. So we just displayed 5 letters. Then on the right is a video of it running. So that's 2 displays chained together. It doesn't actually look like that, but it just looks like that because of the camera that we're using to record. But
All right, and our budget. So since it's our senior project, we're allocated $100 per person, so we have $300 total. As you see here, the rundown of what everything cost us. Our PSoC board is included here, but It doesn't actually count towards our budget since it was a donation and not actually the department had to pay for. And so we have a budget of $214 right now. I forgot to mention earlier the hardware that this could have changed with the casing because we're gonna make a casing for all of this, keep it nice together and organized. I'm working on it right now. Like laser cut plastic, and they also keep all the connections secure so it doesn't get in the way. But this should not actually count towards the budget at all because plastic's fairly cheap and we're just using it from our department.
So to summarize, we have completed the text display on all the displays. We finished all the hardware connections and the chaining as well. So we just need to work on some code, and we also finished the command line interface. So for right now, we're going to work on like adding more colors, like the color options, and then figure out which animations to display as well, and the scrolling as well. And like Nicolette said, we worked on the casing. Then we also have to work on making sure that the command line interface can communicate with the PSoC.
So that's it. We're going to expect to be done all this by April. Any questions at all? Yes.
Why, like on the UART, there's a receiver ISR, but not a transceiver ISR? Is there a reason for that? Or I'm just curious what the ISR is.
Oh yeah, so it's only for the RX because you want to check when the lights come in. So that's the only time we're ever checking for when like the lights go through the RX pin and not the TX pin. So that's why there's only one ISR for the RX and not. We don't need to check. We don't need to check that TX.
Right, yeah, you're just gonna transmit whatever you
Yeah.
see. Okay.
Any other questions? Yes.
So, are you still going that like the lab or exactly kind of 6,000 but like actually like display their achievements connected to like
We are still focusing on it being above the lab. Hardware wise, we just ran into an issue for the casing where like, oh, how is the microcontroller board going to like fit with the dimensions and the power supply as well? Because the power supply, unless you want to do more wiring, which we don't really want to, needs to be in the middle. So that's an issue we're having right now, but we're going to try to put it behind. So it might just be a little bit longer. I forget this, direction in general. But for the computer, we're still just going to have it be able to like plug your laptop in. So that's something we want to make sure we have the microcontroller accessible, so it's still easy to update.
And then like once you disconnect the computer, are you gonna have controller power, whatever the power supply is?
Yeah. Yeah, that the power supply is going to do everything there. So that's not an issue.
You're like when it gets hung on the wall, the wire that connects any computer to the PSoC needs to be longer because it's gonna be at the top of the wall. So we still need to do that.
I saw that your microcontrollers. Are you using just like regular for the sticks?
The development kit, because this one has enough ports. The sticks did not have enough ports, and also, our what's it called? The
RS
serial commands.
Yeah.
That's in the developer kit and not in the stick.
Oh, you need to use like this.
Yeah, for the command line interface. So yeah, that was another thing that we didn't really consider at the time when picking the microcontroller board, but then we realized that it's really convenient we picked that one. Any other questions? Thank you.